Okay. Table of contents. We are now adding two variable inequalities. So with two variable inequalities, there are 3 steps. Make your lines, again, pause it at any point if you need to catch up. So the 3 steps are, the first step is to graph the line or other shape, parabola, absolute value, square roots, whatever. The second step is to determine if the line is going to be solid or dashed. And the third step, I actually say is optional. If you get good at being able to just see these, that's fine. Otherwise, always use a test point. You don't want to choose one that is on the line or on the parabola or whatever the shape is. Has to be off of the actual function to see which side of that shape to shade. So we've got 3 examples, 2 are linears and 1 is quadratic. So here are our first 2 examples. So I'll start with the first one. The first one is in slope-intercept form. So it's super fast to graph. My y-intercept is 3. My slope is down 2 because it's negative, down 2 over 1, down 2 over 1. Now, step 2 says determine if the line is solid or dashed. In this example, our line is going to be dashed because it's not equal to. When we get to this example, this is going to be solid because it has the equals to. So since it doesn't have the equals to, we connect those points with a dashed line. Okay. Step 3 is to pick a point, use a test point, not on that line. My favorite test point, you guys already know my favorite numbers to plug in, would be 0, 0. Test point, that's my test point. So if I plug that in, that means 0 is greater than negative 2 times 0 plus 3. And if I do the math, I get 0 is greater than negative 3. This is, 0 is not bigger than negative 3. So this is a false statement, which means 0, 0 is not a point that works. So if this is not a point that works, then that implies the numbers on this side should work. Now, you can actually just shade it at that point, or I'm just going to show you real quick. You can try a point over here. So let's do 3, 2. If I was to plug in 3, 2, 2 is greater than negative 2 times, negative 2 times 3 plus 3. 2 is greater than, if I do the math there, negative 6 plus 3, which is negative 3, which is a true statement, which means this point here is a solution. So not a solution is a solution. We would shade the sides where all of the solutions would be. Basically, any point within that shaded region is going to be a point that works. And there's an infinite number of points. All of these points are not points that if I was to plug them in, they would work. Okay? So if it's a false, you shade the other side. So shade other side. If it's a true, you shade that same side. Now, I'll tell you about this in class, but I actually can do it with just looking at this. So this is saying y is bigger than that line. So I'm looking at this line. Where does y get bigger? Going up above the line or going down? Y gets bigger above the line. So I would shade that piece without using a test point. And it's fine if you need a test point. The second one, we actually, if you want to graph this, that's fine. If you know how to do it with the x-intercepts and y-intercepts. Otherwise, you could change it to slope-intercept form. So if I change this to slope-intercept form, I would add 3x to both sides. So 4y is greater than or equal to 3x minus 8. And then I would divide by 4. Y is greater than or equal to 3 over 4x minus 2. Because you would have to divide both sides by 4. Now, do be careful. If this had been a -4 and you had to divide by a -4, you would have had to switch that inequality. Okay, the rule still applies. If you multiply or divide anything by a negative, you have to still flip it. It did not happen on this one though. So now I can graph this pretty quickly. I'm going to, let's actually add that to our notes. Change to slope-intercept form. Slope-intercept form. Okay, so my y-intercept is -2. There's my -2. My slope would be up 3, 1, 2, 3 over 4. So I've got my points, and now I have to figure out, is step 2, is it dashed or solid? This one is going to be solid because it's got that equals to line. So I'm going to connect it with a straight line. And now I would use a test point. My favorite test point is 0, 0. Or if you're able to, you could say y is bigger than the line. So where is y bigger, going up or going down? Y gets bigger going up, so you would shade this side. Or we can use a test point, 0, 0. So 0 is greater than or equal to 3 over 4 times 0 minus 2, which gives us 0 is greater than or equal to -2, which is a true statement. This is true. So our test point is a solution, which means every other point on that same side of that line would be also a solution. Okay, I'm going to mark this as our test point. Test point. Okay. Last problem. Y is greater than x squared minus 2x minus 3. It is quadratic. This is a factorable one, so you can box it. So I'm going to box it. Y is greater than x minus 3, x plus 1, which means my x-intercepts, so if we're going to graph this, x-intercepts are at 3 and -1. So I'm going to graph that. So here's -1. Here is 3. Now to graph this accurately, I still need to find my vertex. So my vertex would be my x value, since this is nice and easy, my x value would be right in between -1 and 3, which is +1. To figure out my y, I've got to plug that in. So I've got 1 squared minus 2 times 1 minus 3 is 1 minus 2 is -1, minus 3 is -4. So my y value is -4. So my vertex would be right here. So, and actually I know my y-intercept to be -3. And since parabolas are symmetrical, I actually know this point is also going to be -3. So it would be 2, -3. Because remember, the sides are exactly the same when you cut it down the middle. Okay, so now I've got enough that I can graph that pretty accurately. Solid or dashed. This does not have the equal to line, so we are going to connect those points with a dashed line. And now we have to do a test point. My favorite test point is 0, 0. There's my test point. So I've got 0 greater than 0 squared minus 2 times 0, because there's another x there, minus 3. If I do that math, I get 0 is greater than -3, which is true. So that means this is a solution. So my shading is going to be everything that's inside that parabola. And if you think about it, y is greater. So that means y has to be bigger than the parabola. So if I'm at this point, where does y get bigger? Going up. So in that shaded region. If I'm at this point, where is y bigger? Going up. If I'm at this point, y is bigger, going up. So the shading ends up being inside the parabola.